Hello, today you are joining me on a field trip to Russia. 3 centuries ago, Russian Tsar Peter the Great decided to establish Russian Academy of Sciences. The only problem was there were no scientists in Russia at that time. It didn't stop the Tsar, and he traveled through Europe trying to convince leading European scientists to relocate to Russia. He did not succeed, since Russia was considered an unpredictable and even dangerous country at that time. However, Johann Bernoulli, the leading European mathematician, passed the invitation to his student Leonhard Euler. And in 1727, 20-year-old Euler arrived to cold St. Petersburg, and he eventually became one of the world's greatest mathematicians. In 1735, Euler solved the famous 7 bridges of Konigsberg problem. The city of Konigsberg in the Kingdom of Prussia was built on 2 sides of the river Prague and consisted of 2 islands that were connected by 7 bridges with each other and with the mainland. The problem was to find a walk through the city that would cross every bridge exactly once and return back. Euler not only solved this problem for the small city of Konigsberg with just 7 bridges, he developed a universal idea on how to solve such problems for imaginary cities with millions of islands and millions of bridges. We are in Konigsberg. This is one of the bridges. This is one of the islands. This is another island, and this is the Prague River. And our goal today is to find a walk through the city that would visit every bridge exactly once. There are many strategies to explore. Let's go. I'll meet you at the next bridge. Wait a second. But what 7 bridges of Konigsberg have to do with bioinformatics? It may come as a surprise, but without Euler, we probably wouldn't be able to assemble genomes today. We can think about your genome as a very long strand of 3 billion nucleotides. And 4 decades ago, biologists figured out how to read genomes. But they still don't have a technology that would be able to read the genome from the first nucleotide till the last nucleotide, as if you would read a book. What they can do so is to read short snippets of genome called reads. Something that may be very short, like 200 or 300 nucleotides. The problem, however, is that biologists do not know from what region of the genome each snippet or DNA read came from. And as a result, they have to figure out how to assemble them together. To do this, they generate millions of overlapping reads and use this overlap to figure out how the reads follow each other in the genome. Essentially, it is a giant overlap puzzle. Again, what it has to do with 7 bridges of Konigsberg. Today, we will learn how to build a city with millions of islands and millions of bridges in such a way that every bridge corresponds to a DNA read. And after we learn how to walk in this mega city, you will be able to assemble genomes. I'll meet you at the next bridge after we are done.